Now we're on to the last method of the of our binary search tree. Add was fairly straightforward. We showed that it worked. But now for the remove method. The remove method is the trickiest method because it has more stuff in it, but it's not really too bad once you get the grip of it. So let's go ahead and just make our wrapper method first. Public remove item. We can do a void actually over here, I feel. Yeah. So Yep, we'll just do a void over there. So we will want to, so this will just simply remove an item from the tree if it exists. Okay, and since we're enforcing that there's only one copy of any particular item, then that will be useful over here. And this will be, since we're enforcing that there's only one copy, we can basically stop once we remove one item. So we'll just do this. This dot root is equal to this dot remove root. We want to remove from this dot root the item. So we want to remove this item from the tree that starts at this root. Private node e remove node e item. Sorry, node e root e item. So we want to remove this item from the subtree that starts at root. So first off, if root equals null, right? I think we've done this before, right? We're just going to return null. Okay. Otherwise, we're going to do our comparison again. Int comparison. I swear I know how to spell. It's equal to item dot compare to root dot item. And now here what we're looking for is this base case. If comparison equals 0. In other words, if this item is equal to the item in the root, if this root contains the item we want to remove, instead what we're going to do over here is we are going to return null. For once, we're doing it deliberately. And what this is going to simply do is that, hey, if I've got this item, then I'm going to remove it. And that should work perfectly, right? So like, say I'm trying to remove 10. Hey, I want to remove 15. Oh, sorry, I want to remove 10. 10 is less than 15. We'll go down. We'll write that part later. We get down to 10. All right. Now it's time. Oh, we found 10, right? We're going to return null. Ooh, wait a second. That's not going to work, is it? So that won't work. So this is what's going to make it complicated, right? When we have multiple children removed, right? This is perfectly valid, by the way, for removing 12. If we want to remove 12, boom, 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 boom. We get our way to 12. We zigzag our way down to 12. Remove it. No worries. But on the other hand, removing anything that has children looks to be a bit tricky. So how do we solve that? We'll get into that. So instead, let's just go ahead and turn this into, let's just kind of just, and we never did that. And instead, what we're going to do is that we're going to check the other cases first. We're going to do if comparison, if comparison, so we're going to just do this slightly out of order. If comparison is less than 0, then we want to remove it from the left subtree because we don't have it. So this dot, or rather root dot left is equal to remove root dot left, remove the item from my left subtree. And then return myself to let my parent know, hey, I didn't get removed, I'm still here. Else if comparison is greater than 0, right? We'll explicitly spell that out. In that case, we want to remove the right subtree. Or we're going to remove the item from the right subtree. Root dot right equals remove root dot right. Remove the item from the right side subtree. Okay. That's so far so good. So now we are in that nasty remove case. Okay. So again, what I'm going to do here is that, right, if I remove an item from my left subtree, a node from my left subtree, or my right subtree, that will change what my item is, or what my right child might be. It might be somebody else. It might be null. In either case, what I'm going to do is that I'm going to store it. And whenever I'm done changing whatever that is, I'm going to tell my parent, I didn't get removed. Keep me as is. So let's take a look at the else case. So let's go ahead and just return null here for squashing purposes. So really, removal comes down to 3 cases, which I think I'll separate that into a separate video.